So we are moving forward towards our next questions. We have did 15 questions which were of JEE advanced level. Now we are doing more 15 questions, and these are all not from Singage book. Instead they are some random problems which I got from other other sheets or institutes, okay, you can say. Okay, so this is question number 16. This extra questions will soon be completed, and then we will continue with our Singage, and then we will move on sequence and series. So after completing this, we would have almost completed about 400 to 300 type, means 300 in that range, like this number of questions. So it will just boost your so much confidence that you can tackle any type of questions from quadratic equation. Okay, so this is question number 16, which says if the coefficient of the equation ax square plus bx plus c equal to 0, comma a not equal to 0 are real and roots of the equation are, okay, the coefficients are real and roots of the equation are non-real complex, and a plus b plus c is less than 0. Now if the roots are non-real, then d should be less than 0, right? But if we put f of 1, it will become a plus b plus c, which is less than 0. So f of x is less than 0 for all x belonging to R. According to this, we need to create what kind of equation which are in our option, which can be created by placing 2 in x, right? No, minus 2. Okay, so we will put f x is equals to minus 2 in our given equation, and it should be less than 0. Okay, so 4a minus 2b plus c should be less than 0. So 4a plus c should be less than 2b. Okay, so a is the answer, right? Okay, question number 17. If lambda square plus lambda minus 2 into x square plus lambda plus 2 into x is less than 1 for all x belonging to R, then lambda belongs to the interval. We want to find the interval in which lambda belongs. Okay, now if we take quadratic equation f of x, we have heard f of x is less than 0, f of x is greater than 0. So here they have given, instead of f of x less than 0, they have given f of x less than 1. But we will create f of x less than 0, because for f of x less than 0 we know the conditions. Okay, so we will try to create f of x less than 0 by taking the 1 on the left side. Okay, as lambda plus 2 into x minus 1 should be less than 0. Okay, so we have got our f of x, it is less than 0. Now what are the conditions when f of x is less than 0? It is a less than 0, d less than 0. Okay, then f of x is less than 0. Okay, now let's verify these two conditions. Okay, if it is true, then these two conditions should also be true. So lambda square plus lambda minus 2 should be less than 0. So we are getting here 2 lambda minus lambda minus 2 should be less than 0, minus 1 should be less than 0. So belongs to minus 2 to 1. Let it take as 1. Okay, now on further moving, second condition is d less than 0. So I am solving this condition on the right side. Okay, so it is lambda plus 2 the whole square. I will create a separation. Okay, minus 4 lambda square plus lambda minus 2 into minus 1, it should be less than 0, right? So lambda square plus 4 lambda plus 4. Okay, minus 4 lambda square minus, means here this minus will change its sign, so it will become plus 4. So it will be plus 4 lambda minus 8 should be less than 0. Then it will become 5 lambda square plus 8 lambda minus 4 should be less than 0. like 5 4s are 20 and it should come 8. So okay, 10 lambda minus 2 lambda, okay, minus 4 should be less than 0. So we got our answer plus 2, or lambda minus 2 by 5 should be less than 0. So lambda belongs to minus 2 to 2 by 5. We got these two, let me take it as 2. Then let's plot it in the number line. Okay, we have minus 2, we have 1 here, we have 2 by 5 here. So we know it belongs from 2 minus 2 to 1. Okay, on further moving we know it belongs from this to this. Okay, now which part is common? This part is common. So lambda belongs to minus 2 to 2 by 5, right? But there is no option of such because it is closed interval at minus 2. To verify the whether, to verify at any point whether it is closed interval or open interval, we have to just put lambda equals to minus 2 in the given equation. Okay, in the given equation. Okay, when we put lambda is equals to minus 2 in the given equation, it will be 4 minus 2 minus 2, okay, x square plus minus 2 plus 2 into x minus 1 should be less than 0. These two will cancel out and minus 1 is less than 0, which is true. So we getting less than 0. So lambda is equals to minus 2 satisfy this condition. So lambda is equals to minus 2 should have closed interval. So lambda belongs to minus 2 to 2 by 5. If the option is just check this, because at some points at some close point they may satisfy the condition, so they may be included in the answer. Okay, so B is the answer. Okay guys, now moving on, question number 18. The set of all possible values of lambda for which x square minus lambda square minus 5 lambda sorry, x square minus lambda square minus 5 lambda plus 5 into x plus 2 lambda square minus 3 lambda minus 4 equal to 0 has roots whose sum and product are both less than 1. Okay, so sum of the roots means alpha plus beta is less than 1, and it is telling product of the root is also less than 1. What is product of the root? Sum of the root, it is lambda minus 5 lambda plus 5. Okay, should be less than 1. So moving on further, we can write it as 4 less than 0, and here similarly we will write 2 lambda square minus 3 lambda minus 4, and here we will take this one on the right side, and the equation will become 3 lambda minus 5 should be less than 0. Okay, now this will become 4 lambda plus 4 should be less than 0. 2 lambda square 10. Okay, we want 10, and then okay, 5 lambda minus 2 lambda, okay, minus 5 should be less than 0. Then will be 5 by 2 and lambda will be plus 1. Okay, should be less than 0. Here lambda will be minus 4 and lambda minus 1. Okay, should be less than 0. So lambda belongs to 1 to 4, and here lambda belongs to minus 1 to 5 by 2. Okay, now let's take the condition. Okay, both are less than 1. So let's plot this point. There is minus 1, there is this point 1, then 5 by 2. Okay, and then it is 4. It is telling it's from 1 to 4, and it is telling it is from minus 1 to 5 by 2. Okay, now let's see which part is common. The part which is common is from 1 to, so lambda belongs to 1 to 5 by 2. Okay, intersection. Okay guys, so D is the answer. Okay, moving on further to the question number 19. The difference between the roots of the equation x square plus ax plus 1 equal to 0 is less than, okay, under root 5. Then the set of possible value of a is, okay, Now difference of the root means alpha minus beta, and we know it is equal to under root d upon a, and we write it by mod generally to denote, as we don't know here sign of any root. So okay, so we will put the values here, is less than, and we know it is less than, and difference of the root is less than, so we can write this as like this. So difference of the root means d by a, it is less than under root 5. Okay, now squaring both side, squaring both side. Now here a value is 1, so it will be 1. Squaring it doesn't make any big, so it will b square minus 4. a is 1 and c is also 1, so is b square minus 4, and here it will become 5. Okay, now we will take this here, it will become b square minus 9 should be less than 0. Okay, now it is b minus 3 and b plus 3, okay, less than 0. Okay, then we are getting b belongs to minus 3 to 3. Okay, take it as 1, less than, and has difference between the two roots. Okay, minus p upon a is less than, then the set of possible. Now let's check d. Sorry, it is a, b is a, sorry, this is a, I have written b for the whole time. A belongs to, now let's check the d condition. D should be greater than equal to 0 as it has two roots. Okay, so a square minus 4 should be greater than equal to 0. So here a minus 2 and a plus 2 will appear. Okay, greater than 0. So a belongs to minus infinity to minus 2. Okay, union 2 to infinity. Now let's take intersection of both. So let's plot all these points. Okay, and here it is minus 3, here it is minus 2, here it will be 2 and minus 3. Okay, one it is telling that it is from minus infinity, minus infinity to included. The other it is telling it is from minus 3 to, sorry, this is 3. Okay, not included, and then further it is telling this from here to this. So which part is common? It is minus 3 to minus 2 union 2 to 3. Okay, so A is the answer. Okay, let's move on further. This is question number 20. Okay, all the values of m for which roots of the equation x square minus 2mx plus m square minus 1 are greater than minus 2 but less than 4 lie in the interval. Here its coefficient is 1, so we can directly predict that it can be a parabola like this. Now it will have roots alpha and beta, or it have equal root, doesn't matter, both roots will become equal. So let's see, both roots of the equation are greater than minus 2. Okay, are greater than, so minus 2 will be somewhere here, but less than 4, so 4 will be somewhere here. Then we have to find the interval of m. So let's check the conditions for this. We know f of minus 2 should be greater than 0, f of 4 should be greater than 0. Okay, d should be greater than equal to 0, minus b by 2a will lie between 4 and minus 2. These 4 conditions. So let's check f of minus 2, which is 4 plus 4m plus m square minus 1 should be greater than 0, right? Now this will become m square plus 4m plus 3 should be greater than 0. and it will be m plus 3 and m plus 1 greater than 0. M belongs to minus infinity to minus 3 union minus 1 to infinity. Okay, moving on this, where f of minus f of 4 should be greater than 0, so it will be 16 8, okay, 8m plus m square minus 1 should be greater than 0, right? This will become m square minus 8m plus 15 should be greater than 0. Now 5 3s are okay, m minus 3 should be greater than 0. Okay, so m belongs to minus infinity to 3 union 5 to infinity. Now d should be greater than equal to 0, so let's check this. It is 4m square minus 4 m square minus 1 should be greater than equal to 0. It will be 4m square minus 4m square plus 4. It is always true, okay. Now checking on further which is minus b by 2a. Minus b means 2m, okay, 2m upon 2 into a, which will be 2, and it should lie between minus 2 to 4, and so 2 will cancel on, and this m will lie between 4 to m. So we have one condition, two condition, this is not a condition, this 3 conditions. So just let plot all this. Here we have minus 3, we have minus 2, we have minus 2, okay, we have minus 1, we have 4 3, we have 4, we have 5. In the first it is telling minus infinity to 3 and minus 1 to infinity, and in the second it is telling minus infinity to 3 and 5 to infinity, okay. In the last it is telling from 2 to 4, okay. So from where does it lie? M belongs to similar part, minus, okay, they all have this part common. See, these all 3 have this part common, so m belongs to minus 1 to 3. B is the answer. Okay, moving on further. Question number 21. The value of a for which the sum of the squares of the value of a for which the sum of the squares of the roots of the equation x square minus a minus 2x minus 2 into x minus a minus 1, assume the least value is, okay. We want to find this expression at what value of a gets the least value, okay. So first let's understand what is the condition. Sum of the squares, okay, of the roots means this, okay guys, and what it is equal to, we know it is equal to alpha plus beta the whole square minus 2 alpha into beta. How it came, you can refer to any book, they will teach you. It is very easy, nothing great to explain in this. So we will place b by, which will be a minus 2 the whole square upon a is 1 minus 2 into this 2 will take out all, so it will be a plus 1 upon 1, which is the same. Further moving on, a square minus 4a plus 4, okay, plus 2a plus 2, okay, it will be a square minus 2a plus 6. So we will make a perfect square of it, and we will make perfect square. So how can we make? If we take here 1 from it, it will become a minus 2 the whole square, and this will be 5. So when this will become 0, it will be a perfect square, so its least value will be 5, okay. And so at a is equals to 2, this will assume will get its least value, means obtain its least value. So A is the answer. Now means you can also solve it in this part if you are not able to click that what to do after this. Okay, so you can think like here we want least value of this. Okay, so it is minus b by 2a least value, and it is upward parabola. Understand, it is upward parabola. So in upward parabola we call this value minimum values. Okay, while in downward means in downward facing means its a is negative. In such parabola we take it as maximum value. Okay, so if you try to find minus b by 2a, you will get the same answer, which is 2. So I am just telling an alternate way of doing this if you are not able to click that, because in mostly quadratic equation they teach you to make to find maximum and minimum value by doing this. Okay. 22. If the roots of the quadratic equation, okay, x square minus 2kx plus k square plus k minus 5 equal to 0 are less than 5, then k lies in the interval. Okay, if both roots of the quadratic equation x square minus 2kx plus k square plus k minus 5 are less than 5. Now either here a is greater than 1, a is greater than 1, we got this point. After getting this point, we know it will be something like that. Now both are less than 5. Okay, so 5 will be here, right, and it will be alpha and it will be beta. Are less than, both the roots are less than 5, so 5 is means forward. Now conditions, let's understand the conditions. D greater than equal to 0, this is best condition. F of 5 should be greater than 0, this is the second condition. Minus b by 2a is less than 5. Okay, this is the third condition. Let's check on all the conditions. So first, d greater than equal to 0, which is 4k square minus 4 into k square plus k minus 5 should be greater than equal to 0. 4k square plus 20 should be greater than equal to 0. These two terms will cancel out. 4k less than equal to 20, the k should be less than equal to 5. Okay, we got this from here 1. Now f of 5 should be greater than 0. Let's put 5. 25 minus 10k plus k square plus k minus 5 should be greater than 0, right? So what we are getting from here, it will be minus 9k. Here it will be plus 20, should be greater than 0. Now it will become k minus 4 and k minus 5 greater than 0. So k belongs to minus infinity to 4 union 5 to infinity. Okay, we got this. Let's call it 2. Then here minus p, so it is 2k upon 2 into a, which is 2 only, it is 5. So k should be less than 5. We got second condition. Okay, third condition, sorry, k should be less than. Now let's call out all conditions. Here we have 4, we have 5, and we are playing in it only. So it is telling it is from minus infinity to 4 close, and then 5 to infinity. It is telling it is less than 5. It is telling it is. So which part is common in all? It is the part common is k belongs to minus infinity to 4 close bracket. So B is the answer. Okay guys, now question number 20. If one root of the quadratic of the equation x square plus px plus 2l equal to 0 is 4, while the equation x square plus px plus q equal to 0 has equal roots, then the value of q is, we need to find the value of q. Okay, now the equation, we know it's one root, so 4 into, let's call its other root as alpha. So we have 4 into alpha equals to q. Sorry, we are taking this, let me write these basic things you should do in exam. If you have, it will means will not make you do silly mistakes. 4n alpha, and then this equation px plus q, what we are calling its root, beta comma beta. Okay, now 4 into alpha will be 12, alpha equals to 3, we got alpha. Now 4 plus alpha equals to minus p. Now let's check on the second equation. Sorry, we know p value, which will be 7. Okay, we know p value, we got the p value, which is 7 minus 7. Now moving on further, here 2 beta will be this, from this equation it will also be p, but we know minus p value, which is 7, so we got the beta, which is 7 by 2. Now we got beta. Now the q will be beta into beta, will be q, and it will be beta square equals to q, so it will be 79 upon 4 will be q. Okay, so A is the answer. This was means very easy question. Okay, now if the sum of the roots of the quadratic equation ax square plus bx plus c equal to 0 is equal to the sum of the squares of their reciprocals. Okay, so it is telling sum of the roots means alpha plus beta is equal to sum of the square of the reciprocal, means this. Okay, which will further be simplified as alpha plus beta the whole square upon alpha into beta the whole square, right? Let's put the values. Here it will be b by a minus b by a. It will be, we will write it alpha plus beta the whole square minus 2 alpha into beta the whole upon alpha into beta the whole square. Okay, when we will put it, it will be b square upon a square minus 2 into c upon a the whole upon c square upon a square. Let's put this value in these two, means divide this. When dividing it by this, it will be b square upon c square, and this will be a by c. Okay, a by c, no? Okay, and here it is minus b by a. So how I will, let's take it here and this take here, because there are in when we take APGP there is no negative sum, so we will try to first means eliminate out these negative terms by taking on the opposite sides. So it will become 2ac, and this will become b square upon c square plus b by a. Okay, moving on further, we have 2a by c, which will be equal to b square a plus bc square upon ac square. This one c will cancel out and the rest will multiply that side, making it 2a square c equal to b square a plus bc square. Now let's divide throughout out by a b c. Okay, so it will become 2 a by b, this will become b by c, this will become c by a. Okay, so we got this. Okay guys, we got this. And now this is reciprocal of a, wait a minute, b by c. Okay, these all are reciprocal. Okay, so it is in HP, it is in HP. Okay, so C is the answer. Okay, so we are done with question number 23. The value of a for which one root of the quadratic equation this is twice as large as the other, so it has two roots, alpha comma 2 alpha. So we know sum of the roots is 3 alpha, which will be minus 3a minus 1 upon a square minus 5a plus 3. Okay guys, this minus sign, and we can write it like this, a square minus 5a plus 3. Okay, now let this call this as 3x square 1 minus 3a upon a square minus 5a plus 3 as 1. Let's get the other, which is 2 alpha square Okay guys, which is 2 upon a square minus 5a plus 3, and 2 will cancel out. This will become 1 upon a square minus 5a plus 3. Okay, now what can we do? If we take 3 here and square it, so we can equate this part. So squaring it will make 1 minus 3a upon 9 into a square minus 5a plus 3 the whole square. Now let's equate these two. It will be 1 minus 3a upon 9 into a square minus 5a plus 3 equal to 1 upon the whole square, a square minus 5a plus 3. These two will cancel out. Okay, making it 9a square 45a 15, and making it as 6a plus 9a square. These two terms will cancel out. It will move on here, which will make it 39a, and when this will move on, it will become 14a. 14 is 3. Okay, 27. Sorry, this will be 27. This will be 27. Okay, and then when it will move on here, it will become 26. Okay, equal to 0. Now a will be 26 upon 39, which will be 2 by 3. Okay, yes, 39. Okay, so a is the answer. Okay guys, now moving on, question number 26. Let a, b and c be real if ax square plus bx plus c has two real roots. Okay, which are alpha and beta, where alpha is less than -2 and beta is greater than 2. What here, if first, don't do this mistake, which is drawing this parabola. You don't know the sign of a, it can be negative or positive, so first divide by a, then this will become b by a x plus c by a. These small things matters, because when you will try to attempt J advanced questions, these things are very crucial. Okay, now we will create this kind of parabola, draw this kind of parabola. Now if it alpha and if it is beta, alpha is less than -2, means -2 will lie somewhere here, and beta is greater than 2, the beta, so these two both will lie here only in between. So what are lie here? The condition f of -2 should be less than 0 and f of 2 should be less than 0. So let's try these conditions. F of -2, 4 minus 2b upon a plus c upon a will be less than 0, and here this condition is 4 plus 2b upon a plus c upon a less than 0. Do we see any option? 4 minus 2 a less than 0, this option. Yes, do we have this option? No, we do not have this option only, we have this option only. So D is the answer. Okay, now the condition for a square x की power 4 plus bx cube plus cx square plus dx plus f4 may be a perfect square. We have solved many questions and we have tried to reduce the 4 means a की power 4 type expressions by many quadratic methods or solving it, getting x value, but this question is little different. You must understand, here they have not given you any means number coefficients, so you can take that kind of approach, like divide throughout by x power x square and then try to get x value. These approaches fail here. Okay, or try to break it into linear using ax square plus 2hx square plus by square plus 2gx plus 2f5. Okay, these conditions fail here. So what should we do? This question is unique, just see how to approach it. you must tackle, these questions must go, means you should attempt these questions once before appearing uh, exams like JEE Advanced. So once you know such questions, how to tackle it in exam, it will take you less time to solve. Why? If a student who doesn't have solved this question, if it suddenly appears in front of him, he will be surprised and he will take a long time. If he is smart, it will take a long time for 2 to 3 4 minutes for him to tackle this question. Okay, so it will save your time. So we know the first term will be like this, the middle term can be anything, and the last term will be this. Okay, middle term we don't know, but we can square it. So we will square it, a x square plus mx the whole square plus b square, which is f square. Now 2 into ax square plus mx into f. Okay, moving on further, this will be a square x raised to 4 plus 2a x cube m, sorry I have written x cube here. Okay, m square x raised to x square. Okay, f square plus 2 af x square 2f mx. Okay. Now a square x raised to 4, we have any x, no any cubic, 2am x cube, any square term. Okay, we have this square, m square plus 2af into x square, and the rest is 2f mx plus f square. Okay, we have this term. Now but if we equate it to compare, means compare it with our general equation, the cube, means this cubic term b should be 2am and c should be m square plus 2af. Okay, c should be okay, but how can we create these conditions? That is the okay, here b value we can get from here, b by 2a equals to m. Put it here, it will become c by b square upon 4a square plus 2af. Okay, multiply throughout by 4a square, it will become 4a square c equals to b square plus 4a cube, and it will be 8a cube f, which is this b option. So b is the answer. Okay, we're done with question number 27. So just solve this question once. You must know how to solve this question. It may not come directly, but it can be useful at some point in any questions, what I think. Okay, now question number 28, which is this. So if we take x greater than a, open mod, there is only one approach, take x greater than a or less than a, greater than equal to a. Equal mod x minus a should be greater than equal to 0. Then there are two conditions, x greater than equal to a, x less than equal to a. So we are taking case 1. Okay, greater than equal to a, which will be, so if it is greater than, we can directly open it, which will be 2a into x minus a minus 3a square equal to 0, x square minus 2ax plus 2a square minus 3a square should be equal to 0. Further we write it here, x square minus 2ax minus a square equal to 0. Let's get the x value. X will be 2a plus minus under root, b square will be 4a square minus, this will become plus 4a square, okay, by 2, which indirectly lead to a plus minus under root 2, okay, under root 2 a, it will be a. Okay, we got this. Now x is greater than a, Okay, now these two x value should be greater than a, but we know. So let's examine these two. First is a plus under root 2 into a, and x equals to a minus under root 2 into a, and a is less than 0. So if it is less than 0, this is less than 0, this will also be less than 0. Okay, so both will be negative, means if we take common, this whole will be negative. So can a be greater than this? It will become more negative. So a will be a wait a minute. If a is negative, then after adding this it will become more negative. So x cannot be greater than this, it should be less than. So the condition that x should be greater than a here gets violated, or equal to, means it is negative and it is also negative. These two negatives will add on. Okay, they will means the higher negative or the lower is the value. So this x will not be greater than a, it will instead be opposite, x will be less than a, this a. So we will cancel it, it is not possible. While here a is negative, this term is negative, but this negative into negative, this will become positive, so it will reduce a negative. So x will be greater than a here, greater than equal to a. So here means here this is our right option. So x is equals to a minus under root 2a. Is there any option? No. So let's take case 2. Case 2, which tells x should be less than equal to a, according to which x square plus 2ax, here a negative sign will appear, and minus 2ax, 2a square minus 3a square should be equal to 0. Moving on further, x square plus 2ax minus 5a square should be equal to 0. Okay guys, now let's get the x value, which will be minus 2a plus minus under root b square, means 4a square. Okay, minus 4 minus plus 5, 4 5 are 20 a square. Okay, here it will be 2. If we take a square and 2a common, then these two will cancel out, and these are minus a plus minus under root 2a square. Now what? 10a square. Okay, 10. Here we are taking out, okay, it will be 5, we are taking out 4. This will be minus a plus minus under root a square plus 5a square. Okay, this will be left. Then finally we will write it as minus a plus minus under root 6a. Okay, now let's examine these two. Now x should be less than or equal to a, but here if we let me write this root 6a, and x is minus a under root 6 into a. Okay, if it is negative, this will add on and become positive, this will also add on become positive. Okay, so this will be greater, this x will be greater than this x will be greater than a, while here this a is negative, it will make it negative. This negative will add on and become more, means higher negative number, so which will be less than x. So x will be less than, this condition is satisfied, x should be less than a, but here it is opposite, it will be here negative, it will be positive, it will also become positive. So positive will be greater than a, which is negative, so this should not be possible. So the option is minus a plus under root 6a, which when we take a common, it will be under root 6 into a. This was a J advanced level question, and first B is the answer. Okay guys, okay, let's move on further. For all x belonging to R, if mx square minus 9mx plus 5m plus 1 is greater than 0, then m lies in the interval. Okay, now first you should know if f of x is greater than 0. When it is possible, when a is greater than 0 and d is less than 0. Only two conditions. So m should be greater than 0, first condition. Second condition is 81 m square minus 4 m into 5 m plus 1 should be less than 0. 81 m square minus 20 m square minus 4m should be less than 0. 61 m square minus 4m, so if we take this will become 61m minus 4 should be less than 0, and it will m will be 64 upon 61. Okay, so m should be greater than 0 and m should be, so m belongs to 0 to 4 by 61. Now any option matches? No, it does not. So this option matches was here, it is closed. So what I have told you, to check at any point where it is closed, just put m is equals to 0. Check whether it satisfies the condition of greater than or not. Put 0, then the left term will be 1 is greater than, it satisfies the given condition. So m equal to 0 should be included, should have close bracket, so less the m belong to 0 to 4 by 61. Okay, B is the answer. Moving on to our last question, which says if both the roots of the quadratic equation xy plus x plus p equal to 0 exceeds p, where p belongs to R, then p must lie in the interval. Both roots exceeds, here it is a equals to 1, alpha beta exceeds p. P should be here because these two roots are greater than p. What are the conditions for this? F of p should be greater than 0, d should be greater than equal to 0, minus b by 2a is greater than p. When we put f of p, it will be p square plus p should be greater than 0. P plus p square should be greater than, okay, p into p plus 2 should be greater than 0. Let's plot this point, minus 2 and 0. So p belongs to minus infinity to minus 2 union 0 to infinity. Okay, second is d greater than 0. Second d is greater than equal to 0, which is 1 minus 4. P should be greater than equal to 0, so 4p should be less than equal to 1. Okay, p should be less than equal to 1 by 4. Okay, this is second condition. Now the third condition, minus b minus 1 upon 2 into, okay, this will be become minus 1, should be greater than p. Okay, let's plot all these points, minus 2 0 1 by 8, here minus 1 will be there, and then 1 by 4. Okay, now the first it is telling minus infinity to 2 union 0 to infinity. The second it is telling less than equal to close. Third it is telling greater than minus 1. Which part is common in all of them? 0 to 1 by 4, here this part is common, so minus in anything 0 to 1 by 4, this 0 to 1 by 4 is common in both. Okay, but they have not given that option on it, so we have to choose the most considerable option, which should be p belongs to minus infinity to minus 2 union 0 to 1 by 4. This part is common in all of them, and this part is common in these two. Okay, so this was question number 30 and we are done with. We will do more 9 questions of J advanced level, then we will do multiple choice question, and then we will move on to previous year questions. And after completing these all things, we will move back to Cengage and just finish them, and in 2 to 3 days we will wrap up this chapter and means end all the things with this chapter and just move on to sequence and series. Okay, thank you guys.